Yeah, exactly.
All right, so today I'm going to help work you through a multi-factor conversion. As you can see in my example problem, I've gone ahead and I'm going to use color to help differentiate what we're doing through the problem. So hopefully that'll make it a little bit easier for you to kind of see everything. First of all, it's important to remember that when we're doing a multi-factor conversion, we can convert numerator to numerator, and we can convert denominator to denominator. All right? So let's see. First thing, well, let's go ahead and think about the conversions that we're going to need in order to go from grams to kilograms. Using your metric reference sheet, you should be able to know that a kilogram is equivalent to 10 to the third or 1,000 grams. That's the only relationship that we need for that conversion. We could go ahead and get started with this problem, but let's go ahead and think about all of the relationships that we're going to need. So we're going to focus here on milliliters to meters cubed. Again, when we're converting units, we want to think about the relationships that we might recognize for these different units. So, is there a relationship that I know between milliliters and meters cubed? No, there's not. But you should recognize that there is a relationship between 1 milliliter and 1 centimeter cubed. That at least helps you in the fact that at least it's something cubed. Now you can ask yourself, is there a relationship between centimeters cubed and meters cubed? And there's not a relationship that I've asked you to memorize. So I hope that you can see, if you cover up the cubes, that there should be something that you recognize about centimeters and meters. And let's come over here and write that down. I know that a centimeter is equivalent to 10 to the minus 2 meters. So this would be an example of being able to derive a relationship from something that we already know. Remember, this is a ratio. It is a proportion. It is a relationship. And I can do anything I want to this ratio as long as I do it to both sides, as long as I don't change the proportion. In this case, I want to cube it. So, what does that mean? That means I'm going to cube the number as well as the unit. So 1 times 1 times 1 is 1, and centimeters times centimeters times centimeters is centimeters cubed. Now, just that paper there. If I want to cube the other side, which I have to, I have 10 to the minus 2 times 10 to the minus 2 times 10 to the minus 2. Ultimately, what that means is I'm going to take that exponent and that cube, and I'm going to multiply them together. So I have negative 2 times 3, which will be 10 to the negative 6. And of course, meters times meters times meters is meters cubed. I now have a way to be able to convert from milliliters to centimeters cubed, from centimeters cubed into meters cubed. Let's get started. So we always go back to what was given. So that's our starting point, 0.30 grams and per milliliter. I'm going to go ahead and convert from my grams into my kilograms first. So if I have grams upstairs, I'm going to look at my relationship, and I'm going to put 10 to the third grams downstairs. And right above it, we'll go 1 kilogram. Now also, ladies and gentlemen, since this is a completely metric conversion, I'm going to go ahead over here and recommend that you put that 0.30 into scientific notation. That would be that's going to be 3.0 times 10 to the minus 1, and again, it's grams. So just so you know, I'm rewriting it there. Perfect. My G unit is going to cancel. My units right now are kilograms per milliliter. It's time to focus on the denominator. If I have milliliters downstairs, I'm going to look at my relationship. I want to put milliliters upstairs. And right below it, we'll go 1 centimeter cubed. A lot of times students go, do I have to write that relationship? And the answer is, right now, you need to show evidence that you understand what the relationship is between milliliters and centimeters cubed is. So the answer is yes, you need to write it. But we're not done. Right now we're in kilograms per centimeters cubed. We're going to keep going. If I have centimeters cubed downstairs, using my relationship here, 1 centimeter cubed, and down below it will go 10 to the minus 6 meters cubed. The centimeters unit cancels. My answer right now is in kilograms per meters cubed, which, by the way, is what I'm looking for. That signals it's time to do our equal sign. And let's just take all our numbers and pull them out of this mess, because it gets kind of messy in there. So we've got 3.0 times 10 to the minus 1 kilograms. That's the only thing left there. Divided by 10 to the third times 10 to the negative 6. And we've got our meters cubed. So our units are there. Now it's time to do the math. Now, since I'm going to combine these all together, I could do it any way I want. I'm going to go ahead and combine my denominator right now. When I multiply exponents, I'm going to add them. So 3 plus negative 6 means that this is going to be 3.0 times 10 to the minus 1 kilograms all over 10 to the minus 3 meters cubed. Now I'm ready to deal with my numerator and my denominator. I have 10 to the minus 1 divided by 10 to the minus 3. So we take negative 1 minus negative 3. And minus a negative and a negative is a positive. So you have minus 1 plus 3, which is going to be 10 to the 2. So my final answer is going to be 3.0 times 10 to the second kilograms per meters cubed.